Welcome. In this tutorial, we'll explore the libraries available to you inside a UDF. The Toolkit Instabase gives you for reading documents, modifying them, and interacting with the platform itself. Let's start by reading a document inside Instabase. We'll open up our flow editor and configure our map UDF step using readDocument.udf. Taking a look at the script, this UDF uses parsed IBOCR builder, which is how we open an OCRD file inside Instabase. First, we load the document string with load from string, and that gives us a builder holding every record in the file. We check the length to see how many records there are. For a single passport, that's just one. Now we pull out that record with getUserRecord and start reading it. Calling getText gives us the raw OCR text, and you can see we log both the character count and a preview. Next, getLines breaks the text down into lines, and each line is made of individual words with their positions on the page stored in Word Poly Dictionary. Notice, we can inspect exactly where each word sits, using its start and end coordinates. Then we drill into the page itself. GetMetadata gives us one entry per page, and from there, getLayout tells us the page dimensions and whether it's an image. Finally, we register our function, save it, and run the flow. In one script, we've read a document top to bottom, text, lines, words, and page layout. Reading is half the story. Now let's modify a record and write it back. We load the document using parsed IBOCR builder and grab the first record. A record on its own is read-only, so to change it, we call record.asBuilder, which turns it into an editable record builder. Now we can write. setText overwrites the raw text. Here we're prepending a marker string, so you can easily spot the change. setLines updates the lines array back on the builder. Next, we create our own field. We build a refined phrase, populate its column name as document type and its value as passport, and append it with add refined phrases. Once we're done editing, we convert the builder back into a record using asRecord, replace it back into our document builder with setIBOCRRecord, and call serialize to string to pack everything into bytes. We then register our function. You might have noticed that we are registering the function using register and update the function using name_to_fn as opposed to the register decorator that we used in the previous script. Both of the approaches are valid, and you can use whichever one you prefer. Let's pop into the flow logs from our previous run. Opening the developer logs, we can trace our read path step by step, from loading the OCR record and reading word coordinates, down to line counts and layout dimensions. Now let's switch our map UDF script to modify document.udf, update the formula, and run a test. The key pattern to remember here is start with a read-only record, turn it into a builder, apply your edits, convert it back to a record, and serialize. That completes the full write cycle. The first two scripts worked directly with document data. This third script shows the general tools a UDF uses to interact with the platform itself. FN context is the safe way to access your inputs and system clients. You request client keys by name, and it hands them over. The logger lets you write messages at all standard log levels, debug, info, warning, and error, which you can review in the flow logs. IB file handles file system operations. Here we check whether a folder exists, verify it's a directory, and list its contents. One critical tip, IB file requires a full, absolute file path, so we construct it from the input file's path rather than using a short relative name. Runtime config exposes any runtime settings passed directly into the flow. It's empty here because none were provided. Notice that Refiner FNS and the Token Framework Registry report is not available. This is an important structural design point, not an error. These extraction tools only exist when a UDF runs inside a Refiner step. Because this script is running as a map UDF, it only receives the standard toolkit. Where a UDF sits in a flow dictates what tools it gets. To see the difference, let's open custom refiner functions.py inside a refiner module. Here, because this code executes within refiner, refiner FNS is available directly as an argument, allowing you to run scanning and text cleaning functions like scan, write, and clean. And that's the UDF toolkit in action. You can now create reusable functions to standardize shared logic and efficiently apply it across multiple steps and workflows.